getting started. So today we're going to keep working on our patrol. Oops, what am I doing? Our patrol enemy. Our patrol enemy. Yeah. Let's see what we got on Trello. And I got to tell some people I'm on. I hope everything's going good with you. I hope the world is treating you well. Yup. There's that. Yeah, so I just got to babysit YouTube here really quick, and then we'll get started on our day of code. Not really, it's only a few hours. I only get a few hours of my life every day to do this. But it's fine. It's fine. It's fine, I swear. I don't have a problem with it. Really do like one of the other ideas I've been talking about, and I feel like there's a good promise for it. But let's finish this thing first, huh? Let's finish a game. Now we're working on our patrol enemy, and we've got our code here. We got started yesterday. So basically, this math here determines the starting point for the path that the guard will take on its patrol. So what we're gonna do, sorry about that. Gotta text the wife. So we're gonna go ahead and so let me explain. We've got this thing called a patrol that we put down on the board here, and the deal is you set a guard location, and this tells it where it's gonna patrol. In the case here, we're telling it to look up, basically top. Then if it sees this wall here, and we need to build a patrol path going around the wall, right? So I suppose that means we need, let's move this export up here. I feel like that's a better spot for it. And let's split out some of these variables so they're a little more readable. Okay, so we need to build the patrol location. So we'll call a variable patrol path. And I guess it can just be a set of points in an array. So we'll just go like this. Now we're implying that we're dealing with an array. Okay, now let's build the path. So I think the best way to do this is to build patrol path. And with this function, ith wed, We'll have it build patrol path. I'll go ahead and have it return an array. What are we mad about? What's the problem? What's our issue? Non-void function must return. Let's just return that. You okay now? Thank you. Returns values never used. Okay, so patrol path looks like this. What is going on with this syntax highlighting? Am I crazy? Should this be a different color? Feels like it should be a different color. I got a corner guard here and just, blah, something is wrong with my syntax highlighting. No. Getting rid of that. Is that the problem? There we go. Man, that thing was really messing stuff up. Okay. I think it was fighting with something else. Okay, so build patrol path, and we're going to say starting points. Okay, so we have our starting point, and we're going to use that to determine our this right here. We've got this right here, and we'll go ahead and we're going to get rid of all that. We're going to take our starting point, and this will be, how do we do the math on this? We're going to travel around the edges. So we're building an algorithm. Building an algorithm, which means we're going to have a loop. Most likely. We're going to say, I failed you, Master Wayne. Looks like Cobalt streamed yesterday. I gotta check that out sometime. I think when I'm working on other stuff, I'll do that. Yep. Hey, I was just talking about you. Let's see. So we're building our patrol path. And we're gonna go, the algorithm is gonna go, boop. This is our starting point, clockwise. So the first thing we need to do is look left. So what are we doing? We're building around our area. And I wonder, is there a way that we can do area math? Because if let's say I pretend draw around this, can I increase the size by 1 to make the, no. Because my problem right now is, how am I going to know every time we change, that's the new point? Okay. So we need to build the logic to follow along. We're going to go counterclockwise. No, we'll go clockwise. Follow the maze elements clockwise. And then we'll say, and if we know we're going up from here, and we know we were going clockwise, And let's just pretend like it looks like this. Give it something complicated to deal with, where it's a little more zigzaggy. That way I can deal with potential weirdnesses. Ah, see, that would be a problem if it was like this. No, it wouldn't. It wouldn't be. It just looks like it would be, but I know for a fact. Twouldn't. Twouldn't. Twould that it were. Twouldn't. All right. Twould that it were. How about this? There we go. Let's give ourselves something that could really break. Twould that it were. Twould that it were. Okay, we'll do bottom. Starting from here, going clockwise. How would it know what clockwise is? All right, well, let's find out. Here's what we'll do. Here's what we'll do. Print this out. Oops, hang on. Hold on now. Debug. That's twould that it were. Twould that it were. You don't have an extension for debugging GDScript. What are you talking about? It's right here. Why are we mad? Twould that it were. It's right here. You're literally pointing to it. What happened? Fascinating. Twould that it were. What's our problem? We're connected. This is the... Alright. Now I'm running into just some weirdness. Great. This is cool. Try it now. What? You don't have an extension for debugging. What are you talking about? It's right here. You're pointing it to me, and I have it installed. Okay, let's close Godot and reopen. And then run again. The fudge. I have it right here. It's right here. Uninstall. Reload. Do it again. So now it doesn't even know to call it Godot. Okay. So now it doesn't need a reload. What the fuck? What is going on? Man, this sucks. Is it because I'm not... You don't have an extension for... I literally do. I started a new workspace. Okay. Let's open... No, I started another project for that idea that we were talking about. I just wanted to start like messing around with the data side of the idea. So I spent like 5 minutes on that, and it took me a while to get it going, but then I had to do all this configuration stuff, and now we're in some sort of limbo. And I don't know where. This is my Pac-Man clone workspace. Let's just check. We'll open the workspace again. Okay, so we've opened the workspace. I do. It's right here. It's literally right here. Is it because... Okay, let's do... Here's what we'll do. File. Open. And then we're going to go here. And is it documents? Name? Gosh, I don't know. Respect me. Here we go. Master project. Master project. I'm going to open it from the root. Okay, so now we're in the root. Open folder. Master project, open. Okay, so now we're in the root. And let's say patrol, open that up. Debug. There we go. Okay, so the problem is specific to the workspace. All right, so what do we know? We know that VS Code setting is in here, and it should be move up there. Let's save the workspace, close, reopen. So we've moved the VS Code settings up. Now, there we go. Oh, not quite. Not quite. Okay. Now let's change the settings. So we've got, here we go. Workspace folder / master space project. Okay. Does that fix it? Yeah. Okay, we're good. Jeez Louise. All right, let's get back to business here. Back to what we were doing. Back to life. Back to reality. Let's see, we're going 15.8. One down. 15.8. So, world map 15.8. That's our starting point. Pretty much. Pretty much. Pretty much. So starting point, let's call it starting position. We'll use the same language that we're and then starting position, and then we're going to change this to a variable called starting points for our starting cell. Okay, and now we look around, and the first thing we're going to go is right and say, is there something to our right? Because up. Is there something, how do we know that we're at the top of this thing or that we're in a position that we need to travel to the right? And I suppose the way we do that is we check if there's something above us. And if there's something above us, then we go, okay, is there something to the left of us, for instance, like if we were starting here? Because we know there is something here. Let's try this way. Okay, so we're going to check if something is above us. So starting cell plus equals turn right whenever it can. That would work as well. That might be easy. That might be the easiest. And then if we change directions, we just rotate and turn left whenever we can. That is by far, far simpler. I think you're right, sir. Right, so I think that's it. So that would be on our process step. So we would go func. I think you're right. Delta. Okay. Okay, so we need something called direction. And we need two constants. Clockwise. And how can we do no, we gotta do nope, not constants. And we'll call it patrol direction. And then we'll say clockwise and counterclockwise. Okay, pretty straightforward. So process if patrol direction. Lots of weird variables on this one. I gotta say, patrol direction, we're gonna say by default we're gonna go clockwise. Let's just make sure we get our breakpoint. We don't need this anymore. And I don't think we even need... Yeah, we do need... Do we need starting position? No. 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 Yeah, just turning right seems to be the way to go, because now I can get rid of all that stuff. I don't need any of it. Okay, so there's our breakpoint. So yeah, first thing we do is we try to turn. Ooh. Yeah, it's really cool. So here's a question. What is right? Relative to our direction. So here's what we're gonna do. Patrol now. This becomes guard location. This means this is we need this to be its starting direction. And so how would this work? If we're going clockwise, we should always attempt to go up. Okay, let's think about this. If we're right here and we don't want to attempt to go down first. It would always be up, right, down, and then left to try and go clockwise. No, because then we would loop. So how still? Because we say right, we need to go right, but that's our relative perspective. So if we had an algorithm here, if it attempted to go down, it doesn't find anything. Attempted to go right. So is it down first? Down. Down. Left. Down. Left. Up. Right. Up. So if I had it here and I had the default going down first, it would start going that way. Well, if we correctly set the starting direction, then it could just hug the wall. But we would have to specify what direction it's going to start in. Is that enough, though? Okay, we need to remember. So if we're going up and then we hit a collision, then we need to attempt to go right. Right. Yeah, that's exactly what I'm thinking. And that would be as easy as Felipe, how's it going, man? That would be as easy as it has been. I watched one of your videos. Your English is great. Don't worry, man. Your English is really good, especially for sometimes it's hard to understand Brazilian accent, but yeah, don't worry about it. Okay, so if our last direction was up, our next direction would be right. Next direction, we'll call this next direction clockwise. So if our last direction was up, our next direction would be right. And then if our last direction was right, our next direction would be down. And if our last direction was down, our next direction would be left. And if our last direction was left, our next direction would be up. Okay. So that's our little dictionary for this. Hopefully this is okay. I hope this isn't sacrilege, all these indents I'm doing. Oh, Jesus said hi. Was he streaming right now? Oh, cool. Yeah, I didn't see him. I have him on auto host. I didn't see I was hosting him. That's weird. Oh, you ditched him for me. I bet he's like, Felipe, you're going to have the wrath of Jesus on you. You got to be careful. That's funny. Oh, I have the game running. Oh, you're lurking. So technically you're kind of lurking, both of us, yeah. The dual stream. Why is this running? Force quit. Let's get rid of that. Okay, there we go. Okay, so this is our logic for what direction to try next. Too young to burn. We still need to attach this. I have two choices here. I can tell it the starting direction to head in. Or we could say that this always has a default starting direction, but that would limit us in design as for timing and like say the start of the stage and the placement of the enemy. Or we can attach it to the thing that it's patrolling and determine starting direction based off that. I think for now what I'll do is, since I have this export, well, I got rid of it. Let me get it back. Oh, dang. Well, he's doing all that art stuff. People love the art stuff. That jerk. All right, and then we'll go back to where we were. We'll export this again. He's like making it rain for everybody. Up, down, and left and right. Okay, so these will be, we're going to call this starting direction. Okay. Patrol. What do you call clockwise? What is that called? Like what is that? There's a name for that. Two-dimensional rotation. Okay, so patrol rotation. All right. So we're going to call it patrol rotation, not direction. But they do refer to it as direction, but I think rotations, it makes more sense. All right, so now we have starting direction. Okay, so let's save this and reopen our scene to get our new changes for our little patrol enemy. And now we have starting direction is up. Okay, that makes sense. And so let's do our routine. So what we're gonna do first is we're gonna say patrol direction. So should change your enum to your right. Patrol rotation. Thank you, Consa. Oh, thank you, Consa. All right, and so if we're going clockwise, first thing we do is we try to go what our last direction was. Now we have a variable all the way up on maze object, our parent, called last direction. And so what we're going to do is so first thing always is we try to keep going in the last direction. So let's split this up because I need to remember as much as I code in this, I can't remember my movement code. Let's see, move and collide from transform. And so we'll do, oh, we need a speed on us too as well. We do have a var for speed, but we don't have a set speed on this bad guy. So we'll do, let's get all that set up. Go like this, and we'll say speed equals speed default. Now this is a, what do they call it? I'm referencing reference called speed. And so I got that going. Yeah. Yep. Yeah. So our speed is our default speed. Then we're gonna go and let's go back to our movement code here. Move and collide from transform. So we're gonna do this. And what does it want first? Direction. Delta. Okay, and then in direction, we'll do the math for speed. So direction and speed goes like that. So that's the direction we're going to attempt to move. And then it'll return a collision. So var collision equals move and collide. And if there's a collision, then we try a new direction. So if collision, then we try our new direction. And we need to snap too. So if there's a collision, the first thing we do is snap. And this is the repeating code I'm talking about where I need to write this in a way where I don't have to do this part. But I set position to crossing, something that I have called crossing position. That snaps us to center in our frame and on the maze. So we're snapped. Okay, then we try our new direction. And we base that off of our... I suppose I could make this... So next direction clockwise. I think this is just going to work. I think, so next direction clockwise, and then we're going to look up our last direction equals starting direction. And we're going to go look up last direction like that times speed var next clockwise direction equals this. Next direction, we'll call it tri-direction. Times speed, give the delta, and then we'll say var collision. Okay, I think this is just going to work. Move and collide and transform. What did I do wrong? What is it mad about? Collision is already defined in scope. Okay, fine then. I think this is just going to work. Let's just see. Invalid type in function move and collide base kinematic cannot convert one argument from float to vector 2. And what is it? What is the problem? Let's see. New position is 0. New position delta times direction. Delta direction is 0. That should be a vec 2. So why are we not a vec 2? So it should be var there's no reason for it to be a variable. We'll do func. I mean, it could be a variable. Func direction lookup direction, and then we're going to go and this is going to return vec 2. And then we're going to say return. So we'll make a var here called okay. Oh, it's not. It's an int. My bad. Oh. Okay, so started to move, but then it stopped. So we need to, let's do if collision break. We'll just do a manual breakpoint here. So yeah, I mean, it started moving. That's a good sign, right? Up we go. And a little bit of a jitterbug going on there. Never hitting the breakpoint though. So we're never seeing a collision. Oh, we're not setting last direction. Okay, so if there is no collision, then last direction equals try direction. Okay, so let's see. There we go. And we're going to hit that guy. So I need to get that corner guard out of the way. I think we got it. Oh, wow, he just started trying to go the other way. That was interesting. Let's try it again. Let's go like this. Let's increase his speed too. We've got his speed set to default. Let's go default times 2, which is double. We'll just do double. Oh! So, interesting. So as soon as we're trying our new direction, we also need to be trying the next possible direction. Yeah, almost there. So the problem right now, is I'm only having it change rotation. So if it's going up and it hits a collision here, then it tries to go right. And that's why it goes on forever, because it's never going to get another collision. So I need to keep trying to go in the next possible direction as well. And as soon as I don't get a collision for that, I continue to go that way. So we need to actually attempt to move our next, we need to do this first, this code here first. So it needs to look something like this. And so let's just do var collision equals false to start. Oh, no. Okay, then we don't need to declare that there. So first thing we're going to do is, and let's put this all in a separate function called move delta. And then we're going to go like this, and then we're going to go here and go move delta. So if we need to do other stuff, we can. But then what we can do is, if there happens to be a collision. Okay, so how would this... Well, I'm just going to run this and see what happens. Oh, we're going the wrong way. Okay, hang on. Let's break this down. And try direction equals what? Let's see. Right. Which makes sense because presently we're trying to go up, right? Okay. And we're going to fail. We're going to get a collision. Let's go through and get that collision. If no collision, which isn't what happens. So then we try our last direction, which is up. Should be. So let's see. Negative 128. That's correct. So we should have moved up. We did. So why did we change directions that one time? Let's look at it again. Let's watch this again really quick. So we go up. What? That makes no sense. Okay. See. Let's get rid of this code. Okay. So we're going to try the new direction. If there is a collision, then we basically try the next direction. Okay, so try last direction. Try rotation direction first. Okay. Okay, so we're getting there. So that solves that problem. But why didn't we turn down? Because we should have turned down. So let's get, and really we only need to attempt to do any of this on center. That's what's going on. That's why it didn't fire. So we need to make sure that we're on center. So then, how does this work? Okay, we're almost there. Almost there. Ah. Get rid of that. Get rid of that. Okay. And I do have a check for snap to center. I do. Okay, so then we'll say snap to center is true on this. So yeah, so okay, and then we're going to go if we're at center, then we do this stuff. And I don't like how many nested ifs I have going on here, but I'm sure I can refactor in a little bit here once I get. Okay, so we stopped moving. How come? Because we weren't on center. So we only need to okay, I think I'm getting there. If we're cell center, yeah, exactly. That's the logic I'm trying to put in. So if cell center then we try the new direction. Otherwise, we try the last direction. Okay. If there's a collision, we snap. All right. I think we're getting there. Unexpected indentation. Oh, sorry. And I think, hang on. I think we can do. Yeah, there's more I can do to. I can reduce this check. I don't even need this check. I can get rid of that. But for now, sorry. For now, this'll So if cell center, we try to do this. And then we need to break out of here if we do get a collision. So if collision, at this point, we just return null. We just want to break out. And this guy is going to return null. And then it's going to be mad because I'm not doing this everywhere. So we'll return it after this. And if nothing happens, then we just return null. Is that good? What are you mad about? Okay, well, let's run. Expected return type. Well, fine then. I'm not going to specify. I'm not going to just let me run the code for now. Nothing's happening. Well, this is a great start here. Let's just see, are we breaking on center? Yes. Okay. Oh, no. If collision, then we keep going. So why am I even... Okay, well, let's keep moving. So if there's no collision, that's what it is. So if there isn't a collision, then we return null. We just break out of this. We don't want to do anything else. We did our move. Okay, so we got up somewhere, and then why do we stop? And if there is no collision, then last direction equals try direction. Okay. We don't need this. That's part of our problem. Okay. There we go. Oh, just about. What happened there? Whoa, whoa, whoa. Oh, we got to snap. I'm not snapping. Almost. Yeah, just about. So if snap to center equals true, why did it have that weird pause? That is weird. Huh. Okay, where did we break at? Cell center? Yes. Okay, so we broke at cell center. Try direction is... What was our last direction? Did I set that when we had the collision? No. Last direction equals try direction. So try direction, we're trying to move... We should be trying to move down. Yes. No, that's y. X. Yeah, y. It should be y plus 1. Right? Or is, I forget, is x... Yeah, negative is up. So it's trying to go up right now. So what does it think our last direction is? Left, which is right, which is correct. Oh, we are trying to tell it to go up. If our last direction was left and we collide, so we need to travel around the So if we're going left and we collide, the last direction we went was left and we hit something. Yeah, I'm trying to figure out the logic though of like the search order, because then I can get rid of this, right? I can get rid of this if I set up some logic. So if we give it our last direction, so we could make a function and call it try direction, and then we could say from direction, and it would know what direction we were coming from. How do we... So it would attempt, if we get a collision going left, we would need to try to go up first. And then if we don't hit something, if we hit something going up, then we would need to try to go down. So I actually think this is not anything, I don't need this. I think what we do is we say, if we get a collision, I think I got it. We just multiply by -1 on the direction we want to flip. So in this case, what's happening is we're attempting to go left, and then it says, oh, I can't go left. I don't know why it's doing that, though. And it didn't do it that last time either. But it's attempting to go left. So now we're in our loop here because we're not hitting anything. Well, you say forward, right? Those aren't Cartesian coordinates, so I don't know what forward and back would be in that. Basically, we need a deal for if we get two of these collisions, well, that's why I use the up, down, right, and left. Yeah, exactly. You don't want to go backwards. But in this situation, when we hit something here, we're telling it to try to go up, and then it hits something there. And what we need then is if we hit a collision going this left, and then we try to go up and we hit a collision, then we need to go down. So what we need is for these attempts here, we need to handle... Okay, so we need to handle... Because in both these situations, we've collided. So what we need to do after this is now attempt to go... Because we know that we've tried to go left. We know that we've tried to go... Or we know that, in this case, we know that we tried to go up. We know that we've tried to go our last direction. And so this is where... Here's just to test my theory. What we're going to do is we're going to say else, and we'll set a breakpoint. And the only time we should get this breakpoint is when we hit this scenario where this thing happens. But we hit it right away. No, I don't think it's... I think it's a logic thing. I think it's a logic thing. I think what we need to do... I think... Let's think about this. I think I just need to think about it. I think there's something simple here. Yeah, I mean, I could build a lookup. So, I mean, what I could do is I could do, like what you're saying, Cobalt and Felipe, is I could literally call something direction clockwise. So I have, okay. So, like, it would be like this. It would be... I would build it out to be a dictionary within a dictionary, or an array within a dictionary, and then I would I would go down the list. The problem is, how do I know when to do that? Like, how do I know when to tell it to do that? Because I could try every direction every single time, and then I'm going to break and go this way, up here. Because I need to keep hugging. So, okay, so hang on. Let's think about this. Right. So would it look like... All right. Next direction clockwise. We throw it in an array. Like this. And I have the correct starting directions for each of them. So like you're saying, left you would check up. Well, no, see, you wouldn't check left again because you had a collision going left. So always we try to go the last direction. Then if we hit a collision going the last direction, then we attempt to change directions. If we can successfully change directions, right. Yeah, no, I get that. Yeah, I get the direction order depends, but we always need to be trying to go against except that I don't when I don't. You know what I mean? I always need to be attempting to go in the next possible direction. The problem is that the next possible direction depends on the present direction that I'm going. Okay, give me a second here. I really do need to just be able to think. That's what I mean. Relative to the last possible direction. So like if I'm going up and I hit something, then I attempt to go right. And if that doesn't work, then I attempt to go left. Man. Let's build our... This is a weird problem to wrap my head around. It seems simple. Yes, it seems simple. Let us build a challenge for our guy to go around. So let's get rid of... let me erase him. Let's go back to the maze. Uh-oh, we're getting into swastika territory here. Let me get rid of that. Unfortunately, that design does get us what we need in terms of... So let's just make it nubby. Little nubby corners. Watch the pandemonium. Oh, it's because I... Well, I mean, that's literally what I had. That's exactly what I had, and then we reached that problem where it doesn't work every time. Because we can have a scenario where the wall isn't... Like, if the wall was shaped... Like, let me show you. The logic's flawless if the wall is shaped like this. Right? It's always going to work. It should. The problem happens when the wall has... Ooh. Maybe not. Wait. Let's turn off my snap, too. Turn that off. That might be part of the problem. This is why I wanted to build a path. Ah. Right, down, left, up. If we were going up, we attempt to go right. Well, I was gonna build the path that it would take automatically. So with this, it goes around every time. Right? The problem becomes when we make something like this. Because then it goes, wait a minute. And then now it gets stuck on trying to go, what the fudge? Why is it doing weird stuff like that? Let me double check the patrol. I have it set to go up for starting direction. That's weird. So right here, it wigs out because it hits the wall, and then it's attempting to go up because it goes, oh, we got a collision. So there's different types of collisions, and that's where I like specifying the wall. So we need to know when we hit a collision here and we hit a collision here. I got you. I'm sorry. I'm trying to think, and I'm getting so many ideas thrown at me. So I'm just trying to talk myself through it, and I keep getting different ideas. So I'm just trying to think. I really do feel like this can easily be solved with logic, not with doing rays or anything like that. I just need to think the logic through because it's a logic problem. Yeah, no, it's absolutely a logic problem. I just need to think of this problem right here. I need to think of the solution. And that's all I've been trying to do. But yeah, I mean, there's probably other ways of doing this, but it does seem as simple as long as the starting direction is right, then we can keep trying to move around, and it's just how do we determine how we do that? So it does become, this is the scenario. When we we need to call the two things something, because there's a collision when we're attempting to try a new rotation direction. Then there's a collision when we're attempting to go in our last direction. And it's almost as if so once we have this collision, then we need to try one more direction. But we need it to fire afterwards, but we'll do it now. So we're snapping, and then we need to try, we tried up, then we need to try the opposite of up, which is down. So we need to do this again, but we need to multiply it. We need to flip the positive negative on it. And I believe that is it is concerning though, the I'm trying to remember. How do you do that? I mean, it could just multiply by -1. I know there's a function to do it. Let me just see what this does. And I think we need to, we need to change the, because we're going to go, okay, so we did move, but we need to continue that direction. So if there isn't a collision, so basically the exact same logic we did up there, then we go like this. And I think that'll do it. Yeah. Okay, so let's just, we got it. But we're repeating ourselves a bit here. Yeah, so, and I want to build like the craziest looking thing just to make sure, like have it come out like this and like that and like this. Okay, let's see how it handles that. Oh, so he does kind of a shortcut there. Why? Why did he break out? That doesn't make any sense. All right. Well, I think I need to clean up the code. Take a rest. What are you talking about? I should get some water, though. You're right. Because the code isn't clean. And the other thing is, oh, not me. Oh. All right. Let's think this through. He was taking a rest. We need a lot of things to happen all at once. Yeah. So we need to go down the all of this. We need what I was. We do need to do what. So let's do it, because we need to build. We need to build the array within here, and then we need to say what other directions to check besides. So in this scenario, we're going up, and then we hit something, and then it goes, oh, I want to go right, and then it hits that, and then I say, oh, we'll try to go left, and then it hits that, and then when it goes left, it goes, oh, I got to try and go up. That's the problem. That's the key of this problem. It's all just logic. The thing that we need to do is when we're going up, and we hit a collision. Fudge. I mean, the rays. This should have been simpler. It seems like it's just as it's. It is confusing to me when we're going right. It doesn't successfully go down. And I think something about All right. But really, I don't know why it doesn't go down. So let's just make sure that it can. It can. So why always try to go down? If we're going right, it should always be trying to go down. And we are snapping, and we're only doing it on center, which means that we happen to be moving I did, but there's still some weirdness. It never gets center. I'm pretty sure it's the order that I'm doing things in. There's almost no reason to even test for cell center if we're trying that new direction. And then we get stuck in that loop. Because we go down, we hit it. Yeah, but I'm still having the issue. I think there is a base logic. Yeah, no, I'm trying some different things here. It's when it gets in these corners, that's when it goes, I don't know. And I don't know that, honestly, I don't know that this would happen that often, but we should handle it. But if we're going down, the first thing it tries to do is go left. It'll fail. So we try going down, failed. Try going left, failed. So that's where we need that logic of what directions, depending on the right, down, fail. Then we try and go left, fail, up, fail, right. So is it left, up, right. And what happens if we've applied that logic and the wall isn't there? Then it would go left and it would start going into outer space, going up. So it's left, right, up. If we fell on down. Does that seem good? We hit a wall going down. Or is it right, up, left? Are we always? Yeah. I do want to set things up where I don't need to worry about that. Down, right, up, left. That's just counter. That's what I would expect. See, what I'm thinking about is building out. These are the possible directions to try on a collision going that particular direction. Then it gets real easy, right? We just get the order right per when we hit a collision going in that direction. So then let's just do... so we need to get that order right. And then it gets really easy. So first thing we try to do is move in our last direction. And let's get rid of... We're just going to start from scratch again. Because we need to... Oh, you know what? And our starting direction is wrong for patrol now. It should be right. Right. Okay. So the other thing, though, is that we always want to be trying first. Right. Okay, so we always want to be trying the new direction first. And then if we don't have a collision, we adjust our new direction to that. So this is all still sound. The difficulty, the issue seems to be on when we're not detecting center, because before... Okay. Hold on. Let me hold on to these thoughts. Let me not lose them. I don't know. I don't know if I'm gonna. Gosh, why is this so weird? I mean, I like the way that you're thinking, Dominic. I think this is the right way. It just seems to be something about the edge cases that I need to wrap my head around. Write down so hang on just a second. I know. Sorry, I'm thinking. Sorry. No, I'm thinking. I think I got the conditions that I'm looking for. Oops. Why did we start going? I don't understand. What's confusing to me is sometimes when I start it, yeah, it does stuff like that. What the hell's that about? I'm going to comment that out. Get rid of our... Why is it changing directions now? Okay, nothing's... Nothing's even making any sense anymore. No. I'm going to flush collision out because I'm reusing. Hmm. Yeah, the only time I change the last direction is if we successfully move in the new direction. So it's really not making any sense why this is happening. It's very odd. And it's intermittent, which is even more confusing. Like, I think part of it is we need to, so what we need to do is collision. Here's part of the problem. If collision, then we need to position equals crossing position. Okay, so that's part of it. Why does that happen? How could I have written all that code and it didn't have any problem, and then I reduce a bunch of it, and then now it's just on crack? It's literally like... Let's get rid of these commented out. Let's try again. There's no loop going on here. The only loop is the process step, the physics step. But it's acting like it's looping something, which is not. If there's no collision, we change our last direction to our try direction, and then we return, just to break out of the function, so we don't fire anything else. Now we have our transform that we set, and only if we have snap to center do we set the origin to the crossing position. If we move and collide and there's a collision, we reset the transform. Wait a minute. I think I need to take a break. My brain is mush right now because like nothing is making sense. But I suspect I need to do this. Yeah, we're setting the... But we always go back to the original transform if we crash. Or if we collide. Then we return the collision information. So this is all fine. Why is it doing that like nonsense where it just... Because I want to build off of my code, but like I can't even get it to... Like, what is this? What the hell is going on? Wee. All right. So if cell center, we can try this. Right. We don't have to do it every single time. Good question. Let's find out. Ah. I think I know why now. Because there's no walls for it to collide into. But this is good. Yeah. So it's attempting to... Okay, I think I know why this is happening. Because I think if I go like this and I build a wall around it. Okay. Okay. Let's do, I think I get it. There's our collision. Our last direction. So this is, okay, so this is the problem. So we need to say that we collided attempting to go in our last direction. And this is where I think I need to make this recursive. If we collided attempting to go in our last direction, then the very next thing we should do so we snap center. Now let me go back to here. Let's see what happens after this. Okay. The tridirection is south. We're able to go down. Last direction equals tridirection. That all seems fine. And we should have snapped the player. Yeah. That's why I was building out that array that I was building. Gosh, why does this seem so freaking hard? It's because it doesn't know what it's going around. This is why I was trying to build that path the way I was going to do it. So when it reaches a collision, like we need to treat going in the last direction, that collision needs to be treated differently. But we keep the last direction. We snap on center. And then the next thing that should happen is it goes, okay, well then I'll try to go the other way. So why the heck is this happening where it just wigs out on its own? And it's not going to do it right now. Of course. Of course not. It's been doing it a bunch of times and now it's not doing it. There it goes. Why did it just change directions? So if we get rid of all that and we do this, we're just going to stop. So let's go like this. God, this is reminding me of my old player movement code. Now let's open this up like this. And we'll just create that scenario of okay, so we're stuck in a cell center loop here. So, gosh, this fucking this shit. There is something obvious about this that I'm missing. Yeah, no. There's something obvious that I'm missing. There's something obvious that I'm missing. There is something obvious that I'm missing. I don't have snap on this. Okay. So that might be part of the problem. Okay, so if we're on cell center, we attempt to move and collide. Now let's just paint our rectangle again. And so we snap on when we get those turns in, we snap. Not bad. So now let's handle. See, that's the thing. Like, why the hell does that happen? It's not encountering a collision. Why did that happen? Is it when I'm like clicking out and coming in? Like on a frame drop? Is it a frame skip issue? This has got to be a frame skipping thing. Yeah, I mean, I could set a label here. I think this might be a frame skipping issue. Now, unless I can rewind, which I can't. Well, I should probably end it. I'll wait for your reply, Dominic. This just isn't making sense. Like, I can't even go around a thing. Yeah, I mean that's literally what I'm doing right now, you know? I have this logic is perfect for going around a square or a rectangle. And yet somehow eventually it just descends into chaos. Now, is it because I'm doing 2 move calls? Hey, Felipe. It's only gotten worse, man. Is it because I'm doing 2 move calls in 1 physics step? Is that part of the reason? Dude, it just... Well, see, but in that scenario, like even in that scenario that you're describing, then if I had it like this, and and we were going left this way, if the path in front of me is blocked and the path to my right is blocked, then turn left, and then I keep hitting the wall, which is exactly what's happening in that scenario. But I can't even get the damn thing to go around a rectangle without eventually it just descending into madness, which makes no sense. Like eventually this is going to wig out. And it seems to be happening on frame skips. See, there we go. So if I do something like this, then it's bound to happen. So it's almost like something to do with the frame. If the frame skip happens, then this problem can just creep up. So something about my code and frame skipping there we go. That's how I have the code. That's what's confusing me, man. Like I have the code in such a way right now where it's just like, okay, these are the directions to try. But like that possibility of getting out, that's what's confusing about this is I'm doing that, you know? Like if there's an open wall here and everything else is enclosed, then there's a possibility because of this bug that the enemy can... Sorry, let me just make these clear walls. Okay, so like there's a possibility that the enemy can break out of this and start heading over here. That's why I was so fixated on literally building the path that it would take based on an algorithm that would traverse the walls here and then build the little coordinates right here, right here, right here, and right here. And it would just travel between these coordinates. And then if it was like this, then it would have one here, 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 here. And it would just be an array that it would cycle through. But I think this sort of making it blind Roomba style logic is something about frame skipping or something makes it so that it's not gonna work. Because the other thing, like if I keep, Well, that's why I was trying to. That's why I wanted to build the. Yeah. No, that's why I was wanting to manually build the array. It's just that I would have to write an algorithm that would follow around the walls to build the path. That's where I was going originally. Well, it's still a logic issue, even with arrays, because it can get off path. Like, we know the logic in our head, but if it gets to here and it's like, okay, well, I have array cast over here and array cast over here, you know, we'll tell it to go down. Well, I still don't. I mean, I still like. I'm fine with building the outline of it. You know. I think I need to think about this. I think that there's something I'm missing, like why this chaos is happening. Because I can't properly troubleshoot the logic if I can't even let it just run on its own and know that it's going to be fine. You know? Like, I can't just let this code run and have it be consistent. Because eventually it just wigs out. And that's something wrong in the core of my game. Yeah. I mean, that's what I'm saying I was doing originally. Then Dominic had suggested the idea that, oh, if we always just turn right from, well, not turn, well, yeah, turn right originally, but then, you know, we run into, okay, well, what if the wall isn't a rectangle? And then it's like, okay, well, we can troubleshoot that. And that's where I was going down to start troubleshooting it. But then I realized if I just let this run, eventually just kind of flips out. All right, Felipe. I'm sorry this was such a frustrating stream. Man. What? I don't understand why. But it does seem to be on frame skipping. Like if I go around here and the game is still running, there it goes. No. There it goes. Right. Build the points dynamically. Because I don't... this was supposed to be an easy enemy. It does have something to do with frame skipping. So I do think it has partially to do with this cell center thing. So if I'm always trying to do this move, maybe that'll help with the issue of it. So let me see if I can break it now. There it goes. No, you guys weren't frustrating me. It's a frustrating problem. All right, have a good one. Yeah, no, I got to go too. It's just inconsistent and it's intermittent and it just shouldn't be happening. It does appear to be related to frame skipping, which is concerning because that means the whole game can break if we lose frames. Is there a way I can tell Godot to not... if I fix the frame rate, can I specify... can I tell it to do slowdown instead of skipping frames? presuming that's what's causing this issue. All right. Okay. So if you go here and then you click on the tab Wiki, and we just need to create the first page. Save. So now we've got the wiki going. So if you click on that tab from code to wiki, and then you can edit and start adding ideas or whatever, and then you can create a new page by going like this. Wait, how do we do in wiki? So like this would be new great idea. New great idea. Save. And then if you click on that, it'll take you to a new page with that. Test. So this is a new page. Yeah. Yeah, it's pretty straightforward. It's just that I'm guessing you couldn't even find the tab because I never updated the README. So if I go copy this and update the README, and I go, it's all marked down anyways. So if we go wiki like this, I think that's right. No, it's the other way around. There we go. So commit. Now, if we go back to code, we've got this link to wiki, and then I'll take you straight there. Yeah, I mean, you can edit it all in here. You could download the wiki as a Git repo and then push your updates up. The wiki is all markdown files, so you could download the wiki as see. You got this clone wiki locally, and this is your Git. This would be your Git location to put clone from, and then you could push and pull locally as well if you wanted to, if you don't want to use GitHub itself. But yeah, I don't know. I mean, that's what I'm doing. I thought the logic was pretty straightforward. I'm going blind, but I'm always trying the next available turn. And then we get this weirdness. I'm beginning to think I should completely eliminate using physics for movement. And I think this problem would disappear. Except when the frames drop so badly that what if the delta, let's see. Delta is, let's do this. If delta is greater than 1, debug log. Delta. All right, so that's, we're skipping a frame. See, we're not even, what the fudge? What is this? But the array is checking for collisions. So it's really, it's almost, it's kind of no different. It's just, my movement code is based on this, and I never have this issue as the player moving. Like, I could do what he's doing and have no problems every single time. I'm literally, that's how the player input movement works, is exactly this. So this thing just shouldn't be happening. That's the part that so this is the player code, which we could basically mirror. So immediately the first thing we try to do is, okay, so that's if the player, so this we don't even need to worry about. If the player input does not equal last direction, so in this case this would be if cell center. We snap on that one. And we don't snap on that one. So it's like the patrol enemy is always trying to move in the direction against the wall. Like, that's how I've got the logic set up. Now, last direction. Move and collide. So the difference here, match last direction. So this is happening. Gosh, my dogs. We're just going to go out into space, right? No? Why is this working at all now? Yeah, it shouldn't have worked. Okay. Right, because it's not trying. Mm. Okay. Yep. All right, I think I found the source of the issue. Oh my God. No. I don't know. I'm going. All right. See ya. Thanks for hanging out. Sorry I couldn't really conquer this. None of it's making any sense. Why is this now suddenly changing directions? Like, cell center's not firing when it should. Obviously. Because this should be hitting. Yeah. No, I need to take a break for sure. But we should be going. We don't even need this for now, for what we're doing. But cell center is not firing when it should right there. And then if I start doing, hey, breakpoints, then it wigs out on me. So this is, something's wrong with this code for sure. So I'm going to start to debug this and figure out why we're not good. But I think that's part of this issue, is when cell center fires. All right, have a good one. Once I fix it, the code's only going to be better, right?